Hello students, for today we'll discuss the 21st one. So discuss the continuity of the following functions. So first one is f of x is equal to sin x plus cos x here. So here two functions is there, one is sin x and cos x function. So first we will take here, so g of x is equal to sin x and h of x is equal to cos x. Two functions we are taking, sin x and cos x here. So first we will prove that these two are continuous functions. Then sum and subtraction and division also it will be continuous functions only. So first we are taking, let k be a real number. So if k is a real number, so first g of x is equal to sin x function we are taking here. So for g of x equal to sin x function, what we will get here? First LHL limit we will take here. So LHL means limit x tends to k minus f of x is equal to, limit x tends to k minus, sorry, not f of x, g of x here. So limit x tends to k minus g of x is sin x here. Okay. So sin x function, what we'll get here? So k minus we are taking means which is equal to limit x means h tends to 0. So sin it will become x minus h. Okay. X minus h you will get here. So x minus h is nothing but it is sine of a minus b. So limit h tends to 0. Sine of a minus b, sine a cos b minus cos a sine b. So sine a cos b minus cos a sine b. Okay. If you apply here limit h tends to 0. So sine x into cos h is nothing but cos 0 will get, cos 0 is nothing but 1 you will get, minus cos x into sin h is 0 you will get here. So we'll get here finally here sin x only. Okay. Next, value of the function. So not value of the function, RHL if we'll take here, limit x tends to k plus f of, sorry, g of x is equal to limit x tends to k plus, so g of x is same sin x here, which is equal to limit h tends to 0 plus. So positive means this will become sin of x plus h you will get. So here also same formula we will use here. Sin of a plus b, sin a cos b plus cos a sin b. So limit x h tends to 0, sin a cos b, sin x cos h plus cos x sin h. Okay, so 0 if you substitute here, this is sin x into cos h is cos 0 is 1 plus cos x into sin h means sin 0 is 0 will get here. So this value is sin x will get here. So LHL and RHL both will get sin x only. So value of the function also will get sin x only will get. So therefore LHL is equal to RHL is equal to, we'll get here f of x here. Not f of x, no, g of x will get here. So this is the continuous function. Therefore, sin x is a continuous function. Okay. So similarly, cos x is also a continuous function. Even starting off the classes, we discussed sin x function and cos x functions are continuous functions. So cos x is a continuous function here. Okay. So which means g of x and h of x functions are continuous functions. Okay. Therefore, g of x, comma, h of x are continuous functions here. Therefore, if g and h are continuous functions, then if g and h are continuous functions, then g plus h is also a continuous function, and g minus h also continuous function, and g into h also continuous function, and g divided by h also continuous function, where compulsory h is should not equal to 0 is also continuous functions. Therefore, f of x is equal to sin x plus cos x, comma, again f of x is equal to sin x minus cos x, comma, f of x is equal to, sorry, sin x into cos x is also continuous functions. Okay. Next, discuss the continuity of the cosine, secant, cosecant, and secant and cotangent functions here. So we know that already we have proved sine and cos are continuous functions. So we know that sine and cos functions are continuous functions. So therefore, cos function is continuation means, so cosine also continuation function already we proved here. So cosecant function. So cosecant function, what we can write? Cosecant is nothing but 1 by sine here. 1 by sine function. So cosecant is continuous. So here sine function also continuation only. Why? Because sine already we proved here sine function is continuous. So cosecant is nothing but 1 by sine. So therefore sine function is continuation means 1 by h also is continuation function only. So we are taking here if h is equal to sine x and g is equal to cos x continuous functions means, then cosecant is nothing but sine 1 by sine x will get here. Therefore cosecant also continuous function only. So if h and g are continuous functions, okay, then 1 by h, comma, secant is nothing but 1 by cos, so 1 by z, and h by g also. So h is, sorry, g by h, comma, even g by h also, where h is not equal to 0 is also continuous functions. Okay, therefore cosine, comma, cosecant, comma, cot functions are continuous. Okay, next, find all points of discontinuity of f, where f of x equals sin x by x if x is less than 0, x plus 1 if x is greater than or equal to 0 here. So first we'll take here f of x is equal to sin x by x if x is less than 0, x plus 1 if x is greater than or equal to 0 here. So we are taking total 3 conditions we will get here. So let k be a real number. So first case is, so first we are taking k is less than 0. K is less than 0 means, so we'll get here sin x by x here. So therefore, value of the function, what we'll get here? F of x is equal to sin x by x here. Okay, so where x we are taking as k means f of k is nothing but sin k divided by k you will get here. And value of the limit function also, limit x tends to k, f of x is equal to limit x tends to k, f of x is sin x by x. So we'll get here sin k by k. So value of the function f of x also, limit function also, both are same here. Therefore, limit x tends to k, f of x is equal to f of a here. So f is continuous for all k is less than 0 here. So next, second one we'll take here. K is equal to 0 here. So k is equal to 0 means x plus 1 will take here. So this is f of x is equal to, f of x is nothing but x plus 1. If we are taking f of 0, so 0 we are taking means here 0 plus 1 is equal to 1 will get here. Even limit function also, limit x tends to 0, f of x is equal to limit x tends to 0, f of x is x plus 1, which is equal to 0 plus 1 is equal to 1 here. Therefore, limit x tends to 0, f of x is equal to f of a. Therefore, f is continuous at x equal to 0 here. Next, the case is k is greater than 0 here. Case 3 is if k is greater than 0. So greater than 0 also we are getting x plus 1 only. So here f of x is equal to 0 plus 1 is equal to 1. Even limit function also, limit x tends to 0. F of x also, x plus 1 means 0 plus 1 will get 1 here. Therefore, limit x tends to 0. F of x is equal to f of x here. F of x is nothing but f of a. Therefore, f is continuous at k will be greater than 0. So less than 0 also it is continuation only. Even k is equal to 0 also continuation only. K is greater than 0 also continuation only. So therefore, f is continuous at for all real numbers. F is continuous for all real numbers. Okay. Next, determine if f is defined by f of x equal to x square into sine 1 by x if x is not equal to 0, 0 if x equal to 0. So whether it is continuous function or not, we have to find out here. See, first one x is not equal to 0 we are taking and x equal to 0. Okay, let k be real number. So directly we will take here. So limit x tends to 0, f of x is equal to. So first we are taking for x is not equal to 0. Or case 1 we are taking means k is not equal to 0. So k is not equal to 0 means, so we'll take this function here, f of x. If you substitute here 0, okay, so limit x tends to 0, x can be x square can be written as x into sine 1 by x here. So limit x tends to 0, x into this x can be written as sine 1 by x divided by 1 by x here. Now product of two terms can be written as limit x tends to 0 into x into limit x tends to 0 sine 1 by x by 1 by x here. So if we substitute here limit x tends to 0 x here, we will get here 0 into limit x tends to 0 sine x by x formula is nothing but 1 we will get here. So 0 into 1 is nothing but 0 only we are getting here. Okay. If k is not equal to 0 also we are getting here 0 here. Even value of the function also will get 0 only. So if we find out value of the function, so f of x also if we substitute here f of x, if x equal to 0 here, x equal to 0 also this function is equal to 0 only here. Okay, therefore limit x tends to 0, f of x is equal to f of a. So f is continuous for all real numbers. Okay. Next, 25th one. Examine the continuity of f where f is defined by f of x equals sin x minus x if x is not equal to 0, minus 1 if x equal to 0. So whether continuity or not we have to find out here. Therefore, first we are taking LHL. So LHL means what we will get here? Limit x tends to 0 minus f of x is equal to limit x tends to 0 minus f of x. 0 minus means this function you will get here sin x minus cos x here. So if you substitute here 0, so first one is sin 0 minus cos 0 here. Sin 0 is 0, cos 0 is 1. So 0 minus 1 is nothing but minus 1. Even RHL also. So limit x tends to 0 plus f of x is equal to, so limit x tends to 0 plus f of x is, so 0 plus also will take sin x minus cos x only. Sin x minus cos x is equal to, so here also if you substitute here sin 0 minus cos 0, this is equal to 0 minus 1 equal to 0. So 0 minus 1 is minus 1 will be. Next, f of 0 also value of the function if you find out, already they given this is minus 1 here. Therefore, LHL equal to RHL is equal to value of the function here. Okay. Therefore, f is continuous function.